Alright everybody, we're here with objective 141. Honestly, the best way to start this objective is going to be to pause the video right now and just take down the words that I already have listed. I decided just to have the definitions pre-written, which makes it a little easier and makes sure that I mess up less. So you might just want to pause. I'll talk through it if you also just want to listen and try to write as I'm talking through it. Objective 141, students will be able to understand independent and dependent variables in a function. And if you look through like all these pages real quick that you were assigned, you're reading this word function, but you're just kind of seeing a bunch of equations. It might be a hint, like functions and equations are very similar, if not the same thing. Domain, you see in parentheses, we have the word input. Domain, we can say it's the set of possible x values that make the function work. Let me give one example of what I mean by work. We're not going to run into this in Algebra 1, but I think it's really cool, and it's cool to know. So, domain is the x values that will work in the function. Imagine we had the equation y equals, I'm going to say x squared plus 1 all divided by x minus 1. So y equals x squared plus 1 and then all that divided by x minus 1. Again, we're not going to see equations like this in Algebra 1. But let's say I had x equals 1. I was trying to figure out what would be the output at x equals 1. If I substitute that in, I'd have 1 squared plus 1 all divided by 1 minus 1, and that would be 2 divided by 0. And that should cause you some concern because 2 divided by 0 is impossible. We can't take two things and put them into groups of 0. So x equals 1, the value of 1 at x, we would say it would not work for the function. It would not be part of the domain because it would output a value that's impossible. We're not going to run into that in Algebra 1. I think it's cool to understand when a value would not work. Range is all the possible resulting y values we get from inputting x values. So I'll wait to explain that when we do an actual example. And then for dependent and independent, I want you just to Google search this. I did so myself. I was trying to find the best way to define it, and it made a lot of sense to me when I looked at a few hits. I want you to actually search dependent and independent variables in math, and just read that first search and maybe the videos that follow it. Make sure you say variables in math. If you just search dependent and independent variables, you're likely to get a lot of hits for science because those vocab words come up more often in science. So if you want better math-related definitions, make sure you put this entire thing into a Google search. Alright, so you might be like, whoa, where did this paper come from? Well, if you're in my classes, we did this in class. If you're not, no big deal. What I really would suggest right now is to get a separate sheet of paper just so you have space to write. The focus of this objective is on understanding independent and dependent variables as they apply to functions. But we introduced this word domain and range. I think it's really important to get some idea of what we're talking about. So I'm going to help you understand, hopefully a little better, about domain and range using a few examples from this worksheet we did in class. I'm looking at number 1 in particular. In its simplest form, domain is just the x values of a function. So if I'm going to find out, I'm going to put number 1 right here, and I'm going to get a different marker. 0 for 2. Let's say third time's a charm. So looking at, oh my gosh, I wrote 3. So looking at number 1 right here, if I want to figure out what's the domain, which I'll just label like D with the colons next to it, I'm really just trying to look at what are all the x values in this function. So here are all my x values. So I could say the domain is the values of -2, -1, 0, 1, and 2. That's really all the domain is. It's just all of the possible x values in the function. And because that's all the information I have, I would say, here's the domain right here. Same thing for the range. The range is all the possible y values that result from the x values. So if I look right here, I'm going to use blue. But my range values are just all of these y values. So I would put for my range 7, 5, 3, 1, and 1. And for this function, that is the domain and that is the range. Let's look at number 6. I'm actually not even going to write stuff down here. We're just going to analyze it really quickly. I'm looking at all the x values. these are my domain values, and these are all the y values, my range values. If I were trying to write the domain for function number, or for number 6, it's not a function. I'm not going to explain quite why it's not a function because we're going to do more discussions in class, but number 6 is not a function, but the domain values would be -2, 0, and 2. We would not repeat them, but these are the x values. The y values would be -7, 5, -16, 0, and 6. These are your range values. All of the resulting, the output from your input, those are what we call range values. Number 9 is the last one I'm going to walk through. I'm going to make sure you all can see that, and you can't. Number 9 we're going to walk through together, and I think this is where it might click, like what's domain and what's range. Because we really want to figure it out from a graph. So I'm looking right here. Remember, domain is all of the possible x values, and range is all of your possible y values. So if I look here and I analyze, okay, what are all of the possible x values in this graph? Well, if I notice, there's no positive x values as part of this graph, but it does touch 0. And if I go all the way as far left as the graph goes, -4 looks to be another value, and then all of these values in between. So if I was saying, like, what's the domain, I would write -4, comma 0, and I would put these sort of like rigid brackets on the outside. That implies, and again, this is a little bit outside of Algebra 1, but it's really cool. This implies all the values from -4 to 0 are possible x values in this function. Same idea for range. If you look down at all the y values, well, you don't see the graph coming up here or down here. It looks like the smallest y value possible is -2, and the biggest is +2. So for the range, I would write -2 all the way up until 2, because notice, like, all of these values in between are possible values for the range. So again, domain, the input value, range, the output values. This is a little bit of extra for this objective, which focuses more on the independent and dependent variables, but they are very much connected. And I feel like it would be a disservice not to explain at all, how domain and range are related to this. I'm going to just do 2 examples, because I promised you shorter videos, and I've already kind of talked and said more than I wanted to for this objective. But let's go through this one as quickly as possible without being confused. So, this one provides all the x-coordinates. If you want to plug in your own, you have to. Like, you can. You don't have to. You can provide more of your own input values, but you don't have to. It's just, these are sort of bonus. So right here, the x value is -2. To figure out my y coordinate, again, this is my input. To figure out my output, I'm going to substitute -2 in right here. Put in 2 times -2 plus 1. That would be -4 plus 1, so it would be -3. That would be my y coordinate. My ordered pair would be -2, -3. I strongly recommend that you actually show this substitution for each, but I'm not going to require it. It's ultimately up to you. It's what's best for you as a student. I'm going to quickly go through the rest at my own pace. Let's hope I don't make any mistakes. That one's easy, it's 0, which ends up being 1. Notice how the x value always goes first and the y value goes next. 2 times 1 is 2. This is going to end up being 3. 1, 3. It's 5. 2, 5. And 2 when it's a little tougher, it's 5.6. I think it's 6.6. I'll check that in a second just to make sure that I'm right. So the ordered pair, again, it just goes to x value, which is 2.8, and the y value, which is 6.6. So ordered pairs can be decimals, they can be repeating decimals, they can be fractions, just whatever the input is and whatever you get for the output. This one, I do it without a calculator. I'm going to try. So 2 times 10 over 3 would be 20 over 3 plus 1. I think it's 6.6 repeating. I'm going to get a calculator. I was totally right. I don't know why I doubt myself. So this is going to be 7.6 repeating, because this whole thing, 2 times that, was 6.6 repeating plus 1. I'm going to convert this 10/3 into a decimal. That'll make it a little easier to plot in a second. It's going to be 3.3 repeating, 10 divided by 3, and the output is 7.6 repeating. So now, the last step is just to graph this. And where'd my ruler go? Here's my ruler. So really simple. We're just trying to plot these points. So let's do it quickly because I know you know how to do this. -2, -3 is right there. -1, -1, 0, 1. Again, 0. Don't go anywhere left or right. Just go up 1, 1, 3, 2, 5. And I'm running out of space, but 2.8 is right about here, and then 6.6 would be, I'll say right there. This would be 3.3 repeating with, estimate 7.6 repeating. The last thing I want you to do for every single one of these is you're graphing a line. We haven't said it explicitly, but lines go on forever in both directions. And the reason I'm saying lines is as I graph this, I can tell that this is in fact a line, as it is a perfectly straight line. And like I said, lines go on forever in both directions. Notice how I tried to use up the entire coordinate plane, and I drew arrows at the end to imply that I know, and it tells the reader, that this function, this equation, this line, goes on forever. It's important to include in all of your graphs. Let's do one more. We can do one more. One more example. Okay, last one, last example, and I'll say a few more things, and then you're done. You got this. Keep going. So, we have y equals x squared. Now, this is the first one that's not going to produce a line. And you'll see that in a second. But I already gave you a big hint just now. So if my x coordinate is -4, I'm going to plug it really carefully. No, actually, I'm going to write the whole thing out. You can write the whole y equals equation when you substitute. Totally cool if you didn't up till now. That's also okay. I understand that. That means that the y value is 16. So my x coordinate is -4. My y is 16. Now if I was trying to graph this, my x value is -4. My y value is 16, which is like all the way up there. I'm not going to try to graph it yet. I'm going to see if when I figure out my other coordinate pairs, if those end up on this coordinate plane a little bit better, instead of just estimating, which might throw off where or how the graph actually works. So let's try it again with y is equal to -2. Whenever we substitute, always use parentheses because -2, that whole value is squared, and -2 times -2 is a +4, so y value is +4. Now you see that one we're going to be able to plot, and that's why I waited. Let's keep going. I'm going to pick it up. It's -1, 1. That was easy. It's just 0, 0, 0. Check it out. It's going to pass right through the origin. If I have 1 squared, that means y is going to be 1. This is 0.1 and 1. 2 squared, that's 4. So 2, 4. Then 3 squared is 9. So 3, 9. All right, let's plot some points. First one, I can't plot it on here. If I were to guess, it's -4. And actually, I can't even jump that high. It'd be way up there. So -2, 4 will be the first point that I plot. -1, 1 is right there. 0, 0. 1, 1. 2, 4. And then 3. Let's do a better estimate. It's 7. 7, 8, we'll say 9. So that point would be 3, 9 up there. If I were trying to connect these dots, be nice. So if you notice in this one, it's not a line. This is a U shape, or you might know it's called a parabola. I want you to try to figure out what is it about this equation that didn't produce a line. I think it's pretty obvious. I hope you figure it out. But here's the biggest piece of advice I'm going to give you. Now that maybe you've done all the way up to example 7, you should go to this website, desmos.com. It gives you a chance to actually, if you just say like start graphing, I think, it gives you a chance to punch in these equations and see exactly how they look, so you can check to see if all of your work actually is correct. Now here's my caution, don't just use it to do your homework, do it as a check for your homework. Do it to get an idea of what makes lines look different and why that might be. It's a really fun tool to mess around with, and it's totally free. These are the last questions. I'm not going to read them to you. I'm not going to answer any with you because this is really the test to yourself of what you took away from this objective. It's really easy at the end now just to blow them off, but I think this video hopefully was only like 13, maybe 14 minutes long, so I'm really hoping that you take the time, like you have to take the time to reflect on these, okay? You can do it. Last part, we'll see you in class to practice more. I'm out of things to say.